This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable, source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A roof can look straight at the ridge and still have the wrong load path. The first question I ask is not how thick the member at the peak looks. I ask what closes the roof triangle. Picture an ordinary pair of opposing rafters. Gravity pushes the roof downward. Because the rafters are sloped, that downward load creates a tendency for their lower ends to move apart. That sideways action is outward thrust. The exterior walls may be built to carry vertical roof load, but that does not mean they should be forced outward by an open roof triangle. An A-frame ladder gives me a clean memory picture. The two ladder sides act like rafters. The locking arms between them act like rafter ties. Remove the locking arms on a slick floor, load the ladder, and the feet want to spread. The same geometry is at work in a conventionally framed roof. A horizontal tie connects the lower portions of opposing rafters and keeps that triangle closed. In many homes, ceiling joists perform that tie function. That is why a ceiling joist can be doing more structural work than its finished ceiling makes obvious. Cutting it during a vaulted ceiling remodel is not merely removing material that held drywall. It can remove the tension member that keeps the walls from spreading. This is the central principle I want you to carry through the whole lesson. A ridge board belongs to a closed, tied roof triangle. A structural ridge beam creates a different load path when that bottom tie is absent. The words sound similar, but the forces are not similar at all. The ridge board is the simpler member. It gives opposing rafters a continuous surface for alignment and connection at the peak. Under the prescriptive arrangement described in the California Residential Code, it is not the member that carries the vertical roof load down to the foundation. The rafters bear at their lower ends, and the ceiling joists, or rafter ties, control the outward thrust. The ridge board must be at least 1 inch nominal thickness. Its depth must be at least as great as the cut end of the rafter meeting it. That depth rule matters because the full cut end needs a proper connection surface instead of hanging past a shallow board. The comparison on screen separates the two ridge conditions. On the ridge board side, the roof depends on continuous ceiling joists or rafter ties across the structure. On the ridge beam side, the peak member is structural and carries vertical load to supports at its ends. A ridge beam is not created by casually choosing a thicker board and calling it structural. When continuous ties do not cross the structure, the ridge must be supported by a wall or by a structural ridge beam designed through accepted engineering practice. That is the field boundary for a general building contractor. I can recognize the condition, confirm that the approved plan addresses it, and inspect the load path. I do not invent the beam size from memory. The practical distinction is easy to test in the field. Look below the rafters. If the roof has a continuous horizontal tie system that closes the triangle, a prescriptive ridge board may be part of the assembly. If the ceiling is open and the ties are absent, I expect a structural solution at the ridge, along with end supports and a continuous path below those supports. A common mistake is to focus only on the peak member. The beam itself can be perfectly adequate, and the roof can still have a broken load path if a bearing post stops on a header, joist, or slab area that was not designed for the concentrated load. The correct question continues downward. What supports the beam? What supports that post? And what carries the load into the foundation? Imagine a contractor who is opening a flat ceiling to create a vaulted room. The crew removes drywall, sees ordinary ceiling joists, and starts cutting them because the owner wants a clean open space. Suppose those joists are the members tying the rafter heels together. As the ties disappear, the rafters can begin pushing the exterior walls outward. Depending on the building and the amount of load, possible warning signs include wall movement, cracked finishes, and a ridge that begins to sag. The correction is not to install collar ties near the peak and hope they replace the missing ceiling joists. Collar ties do a different job. The correction is to stop, stabilize the work as needed, and follow an approved structural design that restores a valid load path. That design may use a structural ridge beam with bearing posts, but the beam, connections, posts, and supporting foundation conditions must all be addressed together. This is where plan coordination matters more than lumber vocabulary. An architectural drawing may show a beautiful open ceiling. The structural information has to show how gravity reaches the ground after the old tie system is removed. Before demolition, I want the approved details, the beam specification, connection requirements, post locations, and the support below each post. I also want the sequence clear so the crew does not remove the existing restraint before temporary support and the permanent system are ready. A vaulted ceiling does not make a roof mysterious. It simply changes the route. With a tied roof, the lower tie controls outward thrust and the ridge board aligns the rafters. With a structural ridge beam, the peak carries vertical load to its end supports, and the rafters can bear between the ridge beam and the exterior walls without relying on a bottom tie to keep the walls together. That is also why structural sizing stays on the approved plan or within an applicable prescriptive table. Species, grade, span, tributary roof area, roof covering, environmental loads, connections, and post support can all affect the required design. Guessing from the size of a beam on another project is not field experience. It is changing the design without a reliable basis. Rafter ties and collar ties are easy to confuse because both connect opposing rafters. Their locations tell you their jobs. Rafter ties belong in the bottom third of the roof. They act in tension to resist outward thrust and wall spread. The prescriptive minimum in the research material is nominal 2x4 lumber, spaced no more than 24 inches on center. Collar ties belong in the upper third of the attic space. They help resist separation of the rafters near the ridge under wind uplift. The prescriptive minimum is nominal 1x4 lumber, spaced no more than 4 feet on center. An approved prescriptive metal ridge strap may serve the ridge connection when it meets the applicable size and fastening requirements. I remember the locations by putting the roof on a person. The rafter tie is low, near the belt, holding the body of the roof together. The collar tie is high, near the neck, keeping the collar closed. Belt controls spread. Collar controls separation near the ridge. The important supervision point is what a collar tie cannot do. A collar tie high in the attic does not replace a lower rafter tie. Its position gives it poor leverage against the outward movement at the rafter feet. A crew may install beautiful collar ties and still leave the exterior walls without the tension connection the roof needs. Connection details matter too. A tie only develops its intended force if its fastening and attachment follow the approved plan or the applicable prescriptive requirements. I do not treat a board touching two rafters as proof of a working tie. I look for the correct location, size, spacing, and connection. Here is a quick field check. If I see a tie close to the ridge, I think wind uplift and ridge separation. If I see a tie low across opposing rafters, I think outward thrust and wall spread. If someone proposes removing the low tie because a high tie exists, I stop that idea and go back to the structural documents. Purlins solve a different problem. They provide intermediate support under rafters when the rafter span needs to be reduced. A purlin runs across the underside of multiple rafters, but it does not make load disappear. It collects load, so its braces need a real destination. The reference table on screen shows the main prescriptive checkpoints. A purlin must be at least the required size of the rafters it supports. Its braces must be at least nominal 2x4, spaced no more than 4 feet on center, and installed at an angle no less than 45 degrees from horizontal. The unbraced brace length cannot exceed 8 feet, and the brace must transfer load to a bearing wall or other approved structural support. The angle is more than a drafting detail. As a brace gets flatter, more of the force acts along the ceiling instead of moving efficiently toward the bearing support. The research supports a minimum angle of 45 degrees from horizontal. I use that number as a field screen, then I confirm the approved details. Consider a hypothetical roof where the rafters require nominal 2x8 members, but the crew installs a nominal 2x6 purlin because it is easier to handle. Then the crew lands shallow braces on a convenient non-bearing partition. Two problems appear. The purlin is smaller than the rafters it supports, and the collected roof load has no verified path to a bearing structure. The likely result is inspection correction and rework. Depending on load and stiffness, deflection or finish damage is also possible. Bearing at the ends of framing members is another small measurement with a large load path effect. The ends of rafters and ceiling joists need at least 1 1/2 inches of bearing on wood or metal and at least 3 inches on masonry or concrete. Fasteners can hold alignment and resist specified forces, but they do not erase the need for the required bearing surface. I connect purlins and bearing with one phrase. Collected load needs contact and continuity. The purlin collects. The brace redirects. The bearing wall receives. The framing below continues. If any link lands on a member that was never meant to carry that load, the line may look neat while the structure is still wrong. Roof framing supervision also includes the worker standing on the framing. California changed the residential framing fall protection trigger. An older job site memory can now be dangerous. For residential type framing activities covered by the current rule, employees walking or working on top plates, joists, rafters, trusses, beams, or similar members at 6 feet or more above the surrounding grade or floor level below need fall protection. The revised requirement became effective July 1st, 2025. Conventional methods include scaffolding, guardrails, safety nets, and personal fall protection systems. The method has to match the work and the site. A written fall protection plan is not a permission slip to skip conventional protection because tie-off is inconvenient or production is moving quickly. Current Title 8 contains specific conditions governing when a fall protection plan may be used, including a limited interior framing route when every listed condition is satisfied. The general supervision lesson is simple. Do not rely on the old 15-foot residential framing habit, and do not assume a generic plan covers every crew and every phase. Verify the current rule, the exact operation, the height, the edge exposure, the structural stability, and the protection method before the worker climbs onto the framing. When a plan is allowed, the required roles matter. A qualified person prepares or approves the plan as required, and a competent person implements or supervises it in the field. Those titles are not honorary. They describe different responsibilities for designing the protective approach and recognizing or correcting hazards during the work. There is another framing detail in the safety rule that deserves plain language. Employees should not walk or work on top plates, joists, rafters, trusses, beams, or similar members until those members are securely braced and supported. Fall arrest equipment does not turn unstable framing into a safe anchorage or a safe walking surface. Structural stability and fall protection have to be planned together. Suppose a crew is setting roof members on a single-story project, and the walking surface is more than 6 feet above the lower level. The old habit says the height feels normal for residential framing. The current rule says the trigger has been reached. My supervision decision is to stop relying on habit and confirm the conventional system or the narrow, fully compliant alternative before work continues. I want to bring the structural pieces back together as one inspection thought process. First, I identify the roof condition. Is the triangle closed by continuous ceiling joists or rafter ties, or is the ceiling open? That answer points me toward either a ridge board condition or a structural ridge beam condition. Second, I trace the peak support. A ridge board needs the tied assembly around it. A ridge beam needs designed end support. I follow posts and bearing walls downward instead of stopping my inspection at the beam label. Third, I separate the ties by location and force. Low means rafter tie, tension, and outward thrust. High means collar tie, wind uplift, and ridge separation. One does not casually substitute for the other. Fourth, I check intermediate support. A purlin cannot be smaller than the rafters it supports. Its braces need the proper size, spacing, angle, unbraced length, and bearing destination. I treat every brace as a load path, not as a piece of lumber filling empty attic space. Fifth, I check bearing. I remember 1 1/2 inches on wood or metal and 3 inches on masonry or concrete. Then I verify the member, connection, and plan condition, rather than turning a minimum into a complete design. Finally, I check the people and the sequence. At 6 feet or more on the covered residential framing members, the current fall protection rule is active. The framing must also be braced and supported before employees walk or work on it. I want the protective system ready before the exposure exists, not discussed after someone is already on the top plate. Here is the compact memory chain. Close the triangle, choose the right ridge, trace the posts, place the ties by force, send purlin load to bearing, provide the required contact, and protect the crew at the current trigger height. Based on the published CSLB study outline, roof framing and personnel safety fall within testable material. The useful way to study this is not to memorize isolated words. Attach each word to the force or responsibility it controls. Ridge board means alignment inside a tied triangle. Ridge beam means vertical load at the peak and support to the foundation. Rafter tie means outward thrust. Collar tie means ridge separation under wind uplift. Purlin means intermediate support with a continuous bearing path. 6 feet means the current residential framing fall protection trigger. Before I let you go, I made an audio practice quiz specifically for this episode on rafters, ridge boards, ridge beams, ties, purlins, bearing, and framing fall protection. It is audio-based. The questions are read aloud, and you answer by tapping, so it works for people studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. I read those questions, and they help me make the next lesson more useful. Subscribe so I can help you stay on track through every episode until you get your license. I know how much work it takes to study around real jobs and real responsibilities, and I am rooting for you all the way to that license.